Up to this point, we've covered a good amount of topics, and we've pretty much covered all the essentials that you might look at when using the Bash shell. Now, I wanted to add this last section in because there are a few topics that you'll probably stumble upon in the near future, and I wanted to go through some of the common commands and concepts related to them so that you know kind of how to get started when you stumble upon them, if you haven't already. So the first one that we're going to be talking about is regular expressions. And to talk about this a little bit more clearly, I'm going to jump into Visual Studio Code. Now the reason I'm doing this is because if we went into the terminal, so let me transition over into the terminal, you can see that when we run a regular expression search, you're not actually going to be able to see the matches that we're matching until the output is printed. So you can see that we have highlighted the word text and it's in red, but we don't see this until it is outputted, and especially if we were to come in and try to, cat out some file.txt into the grep utility, we're not going to see what's actually in that file until it is matched in the output. So to better understand regular expressions, we're going to go into Visual Studio Code where we can get live matching. So as you can see, I've done a literal text search for the word text in this file, and you can see here that it's actually highlighting it in my code editor, and you can see immediately the output of our regular expressions. So we're going to stick with Visual Studio Code here. And before we get into the details of regular expressions, I wanted to take a quick step back and understand what they are. So when I first started, I was very confused as to why we were using these, and the reason being is because sometimes literal text searching is not adequate. And what I mean by literal text searching is, quite literally, we're going to take every letter and try to match that. So in this particular search, we have our search term up here, and then we have our search contents over here on the right. So what it's going to do with this literal search is it's going to take this file and it's going to read it character by character, and it's going to say, okay, we've got an S. Does that match the first letter of our search term? No, so let's move on. We'll go to O. Does that match? No, so let's move on. It'll get over to the T and it'll say, okay, yes, that does match. Let's advance to the next character in our search term. So we get the E, and then we say, oh, look, that matches too. Let's advance to the next one. We get the X, and then another X, and then so on and so forth until it either doesn't match and we return nothing, or it does match, as in this case, and we highlight the word text because it has matched successfully. So that is what literal text searching is. But what regular expressions offer us, especially in the context of the grep, sed, and awk bash tools, is the ability to match not only literal text but also patterns. So here below you see that we have two email addresses, and the way that we might match that with regular expressions is like so. So we could say something like dot plus and then at gmail.com, and you're going to see that this matches both of these email addresses. Now, of course, I have not explained what this means yet, but you can kind of see the power of this, how we can match multiple pieces of an entire file, not based on the actual text, but based on a pattern of text. So this is very applicable to validation within web applications, with input forms, and even there's a lot of coding applications to this too. So the first thing I wanted to do before we get into the actual rules of regular expressions is walk you through the differences, or maybe non-differences, between different implementations of regular expressions. So when I first started out, I was under the impression that regular expressions were different for every single implementation. So if I was writing Python regular expressions, that was going to be different from JavaScript regular expressions, which was going to be different from Bash regular expressions. But that is simply not the case, and I want to quickly demonstrate that to you right now. So we will start off with Python regular expressions, and to do this we import the regular expressions module, and then we perform a method called search. So in this search method, what we're going to do is put in our regular expression right here. So I can actually copy in the same thing that we wrote up in the VS Code search tool. And then in the second parentheses, we can type in, an email address or a pattern that we want to match. Or not pattern, the text that we want to match. So when I press enter, it's going to show us that we have successfully matched a particular, object. So this is going to be printed out. If we'd have to actually append the group 0 to the end to get the actual match. But that's just a nuance with Python. That's kind of just an implementation detail. Overall, what I want to point you towards is we use the same exact regular expression here as we did up in Visual Studio Code, and as you're going to see we do with JavaScript when we enter the Node console, which is a JavaScript engine. So we could say my regular expression equals, and then we will print in or copy in the same exact regular expression. Notice this time we're not using quotes, we'll use these forward slashes. That's just how JavaScript interprets them. And then finally we can execute the exec method against a particular string, such as bob23@gmail.com. And you can see that we've matched it. Now finally, if we exit out of here and then we do something like, we cat out, I think I need to get into documents first, and then we cat out the regular expression.text into the grep regular expression utility, and then we put in our same exact regular expression, you'll see that we match the two pieces of text here. So as you can see, no matter if we're working in Visual Studio Code search tool, the grep search tool, or even Python or JavaScript, it's all going to be the same. So you only have to learn the rules of regular expressions one time, so you can find some comfort in that. Alright, so now let's get to the actual hard part where we have to learn regular expressions. And to do so, we're going to have to learn what these little meta characters mean. And I'm actually going to tack on here, well maybe I'll go on a new line, and we're going to tack on a few more. So /W, /S, and / I think it's B. So, or no, not B, it'll be D. So those are additional characters that we're going to have to learn. And if you can understand everything right here, then you're going to understand regular expressions. We're going to kick it off with the characters right here. So this little caret and the $sign. Because these two characters represent what we call like a boundary of a particular line. If you're not familiar with basic computer science topics, or maybe you just haven't programmed in a language like C, you need to understand what the end of a line actually is. So if we went up here into the search bar and we matched /n, and for those who are unfamiliar, most people will be familiar that this is a Newline character. It's very different from these little meta characters that we have in our regular expressions below. Anyways, this is a Newline character and it happens at the end of every single line. So you can see when we press enter, we're going to match this little invisible kind of space here at the end of each of these lines. And the reason that we've matched these is because there is this invisible Newline character at the end of each. Now at the beginning, there's not really anything that indicates the beginning of a line other than the first character. So the last character in line 2 right here would be the Newline, but the first character would just be B. So that's kind of the boundaries, and we can use the caret and the $symbol to represent the beginning and the end of each line. If we put in a caret and then a $sign, or not a percentage, a $sign, and press enter, we're not going to get any matches. And that is because we haven't matched anything in this document because we haven't actually provided any symbol. So the only way that this is going to work is if we put something between them. So this would basically represent the beginning right here. So maybe we could, maybe what we want to match is line number 2. So it starts with a B. So we'll say starting at the beginning of the line, then look for the B character. And then at the end is an M. So we can put an M character, and we would expect this to match, right? Well, if we press enter, we might notice that it's not going to match. Now, we're getting there, but we still need to include characters between the B and the M. So to do that, what we can throw in there is a period followed by either a plus sign or a star. And we'll get into that in a second, but if we press enter, now we're going to match that second line where it starts with a B and it ends with an M, indicated by these two little meta characters. Now, as you can see, we've also got two meta characters right here in the middle, and they do something a little bit different. So we're now going to transition into the topic of pattern matching and quantifiers. So this little dot, or the period, is not how a period normally works. So if you turned off regular expressions here and you just searched for a period, you're going to match all the periods in your text. But if you turn on regular expressions, notice that you match everything. And that is because the period represents everything except for a new line. So it's not actually matching the new line at the end of each of these lines, but it is matching every other character. Now, the one thing in regards to this is we have to add a quantifier to the end of a particular character or meta character to tell the regular expression how many of these particular characters we want to match. So let's go back to the example where we had this little caret and the $sign, and then we started it with a B and ended with an M. So again, this is on track to match the second line. And when we put the period in there and then we give it either a plus or a star, we're basically telling it we want to match one B, then we want to match any character in a quantity of, in this case, 0 or more, that's the star, or if we put the plus sign, that is 1 or more. We can also use the little bracket here to quantify things. So we've learned the star, which is 0 or more, the plus, which is 1 or more, and we didn't look at this, but the question mark is 0 or 1, so it's only two possibilities. Now you can do custom quantifiers with these little brackets. So if we came in here and replaced our plus sign with the brackets, we can throw in any quantity that we want. So we can say 1, so we're matching a B at the beginning of the line, and then any character in the quantity of 1, and then an M at the end of the line, which obviously is not going to match anything, as you can see here. But if we extended this and we put a comma and then maybe 20, so match any character in quantity of 1 to 20, that's going to match this line here because we have the B followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then an M. So we'd actually go 1 to 14, that's going to match, but if we say 1 to 13, it's not going to match. We can also do some short code here, so if we just put a 1 and then a comma, that means 1 or more. It's the equivalent of a plus sign. Or we could say 0 or more, which is the equivalent of the star sign. So that's basically how we use these brackets as quantifiers. Alright, so now we can get into these three little guys right here. And they represent, kind of similar to how this period represents any character except the new line. these three little meta characters, as I'm calling them, I guess they're not technically meta characters, will match different types of things. So the W is going to match anything that's alphanumeric, so essentially any letter or number, but it's not going to match like the @ symbol or the dot. So that's what the W matches. The S matches any white space character. So let me just start throwing these up here. If we do the /W, you can see what it's matching here. We're matching everything except the dot and the @ symbol, and then all of the meta characters. And then if we put an S, that's going to match all the white space, as you can see. So that's all the white space. And then the D is going to match any digit, so the 2, 3, and the 8, 2. So that's kind of useful if you're just trying to match certain types of characters. So if we wanted to match line 2 using just these guys, we can say something like, since we have alphanumerics at the beginning, so letters followed by numbers, we could say we want digits in the quantity of, we'll just be explicit and say exactly how many we want. So 1, 2, 3, 4, 5, 6. So we want digits in the quantity of 6. Then we want an @ symbol, and then we want characters, so alphanumeric characters again in the quantity of 5. So we can do the /, and excuse me, this is actually a W, not a D. That would be digit. We can do /W in the quantity of exactly 5, and a dot, and then finally a /W in the quantity of 3 for COM or com. And when we press enter, we're going to match both of these email addresses because they are the same length and they match the same exact pattern. Now if we threw in just one more letter here and pressed enter again, it's only going to match, well, it should match that first one. I don't know what is going on here, why it does not. And that is because somehow, some way, we have a little / here at the end. Not really sure how that happened. And as you can see, we are matching only part of the second email address. And if we actually threw in a beginning of the line right here, it's not going to match it at all because we want to match 5 characters or 6 characters here at the beginning of the line, followed by an @ symbol, and this is actually 7 characters followed by an @ symbol, so that's why that would not match. Okay, so we have gotten through these meta characters here. One thing, you can actually reverse them or negate them by capitalizing them. So if we wanted to match everything except for digits, we could do a capital D, and as you might guess, it's going to highlight everything except these 2 little numbers. So we've got everything except the 2 numbers. So that's kind of how you negate things. The last thing that we have not covered that I do want to get to is these little brackets here. So before I get into them, I'm going to just kind of explain why we don't cover these things right here. These little parentheses represent groups and are very useful, as we saw earlier when I did the Python regular expression. We actually could print out different subsets of the regular expression using different groups, and this allows you to kind of separate out really long regular expressions and reference them in your code. So not really applicable to what we're talking about, so we're going to skip over that. And then these last 2 characters are not really regular expression meta characters. They're more like just general coding, computer science meta characters that you can use. So usually the pipe would be an OR indicator, and I know we've been talking about that as like the pipe command in Bash, but in general that would just mean OR. And then the / is generally just going to be the escape character. So for example, if we wanted to actually match the periods in this text with a regular expression, we can't just type period because that highlights everything. We'd have to escape it by putting the / and then period, and then we're going to actually get the period. Alright, so those are the last couple characters, but now we're going to get into these little brackets, which are not quantifiers like these other brackets, but they are actually called character sets. So in most cases, you're going to get everything that you need with these three guys and the dot and then literal text matching. So, if we just literally wanted to match BB, we could match BB. This little character set allows us to customize things a little bit more. So instead of using the /W, which matches anything alphanumeric, what if I just wanted to match lowercase letters? Now, I couldn't do that using what we have right here, but I could do that with a character set. The way that I'm going to do that is by typing these two brackets and then type lowercase a to lowercase z. So that's going to qualify every single lowercase letter in this file. And you're going to see that all these are matching now. Now, if I wanted to maybe exclude the, or maybe I just want A through D, we're going to see that it only matches A through D now. So as you can see, these little character sets allow us to really customize what we're searching for in terms of patterns. And you can get pretty crazy with it, so you could say anything from A to Z lowercase, A to Z uppercase, and 0 to 9, which would basically be alphanumeric, or in other words, the /W. Or you could just, type in maybe A to D and then 1 to 4 or something like that. And then you're going to only match A through D and 1 through 4. Don't need to go into that too much further. Hopefully you understand what's going on there. Now, the last thing that we're going to go through is a simple example. And if I scroll down here, you can see I've put in a series of addresses. Let me just clear this out by searching for something random, maybe like a space. And we can see that we've got mostly emails, all of different domains, and then 2 lines in here that are not emails. So if our goal for this particular file, as we're going to call it, is to match just the email addresses, we could go about it, many different ways. So I'll just demonstrate a few of them just to show you how flexible regular expressions can be. So the first way that we might go about doing this is by matching, starting at the beginning of the line, we want anything, or actually no, we want to do alphanumeric because, no, we can do anything because you can put actually dots, periods in your email address. So we can do dot, and then we want 0 or more of those characters, followed by an @ symbol. And then we want to say, we can't just say, gmail.com like we did earlier because there's a yahoo.com, a custom site, and a Hotmail. So the way that we have to do this is by saying another dot for any character in the quantity of 0 or more, followed by a .com. And you're going to notice that this will not work at the beginning because the dot has not been escaped and therefore is trying to match everything. So we need to escape that first, and then it should match everything here. So I'm trying to understand why this is not matching. We have the beginning of the line, any character in 0 or more, followed by an @ symbol, and then any character in 0 or more, followed by a .com. And that is because it did not work because we actually had a space at the end of our regular expression, which is going to count for something. So we have to take out that space, and then it finds the email addresses and not the non-email addresses. All right, so how could we rewrite this to be a little bit different? Maybe we could replace all the dots with character sets. So maybe we want to match anything. We want to match a dot and this brings up a very important point. When you have a character set, all the rules that apply previously do not actually apply anymore. So we can literally match a period without escaping it within the character set. So we want to match anything that's either a period, a lowercase letter, or maybe a number. And when we press enter, it's going to still match everything. So we can once again replace this over here with a dot and A to Z, and then 0 to 9. You can see we're getting pretty long with this regular expression, but it still matches. So you see there's multiple ways that we can match different things. I've kind of taken it back to our original expression because I just like it. It's shorter, more concise, and it does the job. Now let's think about a way that we might be able to break this regular expression. So what if we had something in our text that could actually break the regular expression? Like maybe, let's see, what if we didn't have a .com at the end? So what if we put an email in here, custom email at some site.net. Now, when we press enter, we're not going to actually match that, even though it's a completely valid email. So we're going to have to kind of rethink what we're doing here with the email addresses and modify our regular expression. And this is a very common thing when we're dealing with regular expressions because you're often going to have to tweak it a little bit here and there to get the result that you want. And it's not going to work out the first time. You kind of have to write your regular expression and then test it on some sort of data or text that you're matching, and then just iterate as you go along. So in this case, a simple solution, we didn't actually cover this whole grouping thing, but we can throw in the parentheses and say com or, so we use that little pipe or character, and then net. And you can see now it's actually going to match that last email address. So just a quick example there. But the main thing that I want you to get out of this section on regular expressions is that, number one, they're going to be the same no matter what language or implementation you're using, or at least they'll be very, very similar. If, maybe there will be a few nuances, but for the most part, you're going to be dealing with these characters here, and they're going to apply in some shape or form. And number two, I want you to understand that there are literally 100 ways to write a regular expression for the same exact text. I could go on and match this line number 2, in literally 20 different ways within a couple minutes. And that's just because there are so many options here. So if you can grasp those two things and understand what these meta characters do, then you are very well on your way to using regular expressions effectively.